Hello fellow problem solvers. So today we're going to be doing a problem from my first team selection test back in 2012, problem number 4. I suggest you try this problem out actually for a minimum of half an hour, no matter your level. A minimum of that, ideally an hour to an hour and a half, not more than 2 hours, not more than 2.5. If you'd like to go along with us, give it a go for the next 15 minutes. 20 minutes, write your first ideas out on paper. And if you're new to this sort of thing, especially do that if you're new to competitive mathematics. I had 4 out of 10 points on this problem. And in this team selection test, I ended up being 13 out of 40 people. I thought that I aced everything, though that was not the case. Now this problem is pretty cool. So we have ABC, CD, ABC are the side lengths of a triangle with perimeter equal to 1. We need to prove an inequality. So there are many questions here. First is, how do we use the fact that these are side lengths of a triangle, right? There's a question there. How do we do that? Another question comes up, okay, a plus b plus c is 1. How are we going to get to this inequality, right? It's not a standard. We need to maybe use that A, B, and C are lengths of a triangle. And now there's 2 things I want to show you. One thing is making things homogeneous on both sides. So to be able to work with something here, like this inequality is true if and only if 2a squared plus 2b squared plus 2c squared plus 8abc is less than 1. Now what is 1 equal to? I want to get rid of something here. How will I do that? Well, I'll set 1 to be equal to a plus b plus c squared. And now I'll get rid of some of the squares and I'll have this whole thing is true if and only if a squared plus b squared plus c squared plus 8abc is less than 2ab plus 2bc plus 2ac. Now one question is there any way we can move forward? There are 2 ways we can move forward. One is to try to continue and factor this. Actually, continue to homogenize this, which is now we multiply this by a plus b plus c, and this by a plus b plus c, and then see what we get. And let me go down that route to see actually what it is we'll get. So we'll get this whole thing is true if and only if. So when we multiply this by a plus b plus c, which is 1, what do we have? We will have a cubed plus a squared b plus a squared c plus b cubed plus b squared a plus b squared c plus c cubed plus c squared a plus c squared b. Then we have plus 8abc, which kind of looks like a plus b plus c cubed, but isn't quite, it's not really equal to that. And this thing becomes less than, so we have 2a squared b when I multiplied by a, when I multiplied by b, 2ab squared plus 2abc plus 2abc plus 2b squared c plus 2bc squared plus 2a squared c plus 2abc plus 2ac squared when I multiply everything through. And now what cancels out? Well, 2abc, 2abc, and 2abc cancel out the 8, make it a 2. We have a squared b squared twice. Here we have it once. So these things cancel out these 6 2's. And we're left with needing to prove that a cubed plus b cubed plus c cubed plus 2abc is less than a squared b plus a squared c plus, b squared a plus b squared c plus c squared a plus c squared b. Now what do we do? We're still not done. So here I can invite you to pause actually and try to push the problem further for the next 5 minutes. see what you get. What do you get from here? And here's the next sort of idea. So we have a squared b. Now I can sort of undo me homogenizing it and see if I get something there. So I can like get a squared out and then write this as b plus c, which I know is going to equal to 1 minus a. Maybe that's something. And now when it's 1 minus a, I can combine this with the cubes. And I can do the same thing with all of these. And I end up needing to prove what I just had here. So undoing this homogenization doesn't really work. And so here we get stuck in some sort of a rut. Can we do anything else? Well, we haven't used the triangle inequality in any way, shape, or form. And here it's not, it seems like it's just almost as good as we need it to be. Because we have b plus c is greater than a, and then we'll get rid of a cubed, b cubed, c cubed, but we'll be left with 2abc, which is just no good. But we're so close. And if you get to that point in your exams, write it down. You might get some points out of there. I think I got the points because I just had the triangle inequality. A plus b is greater than c. So this is not working out very well. Let's get back to here. What do we have? Well, let's see if we can factor this in any way, shape, or form. So if we move everything on this side, it's equivalent to, so we're going to have a squared plus b squared plus c squared. This thing right here is equal to 1 minus 2ab minus 2ac minus 2bc. And it's like, I'm not maybe doing much, but I'm like sort of returning back to the original thing I had. And then if I put everything on this side, I'll have 1 minus 4ab minus 4ac minus 4bc plus 8abc needs to be less than 0. Now what do I do? Well, I want to factor this somehow, and to get ABC, I need to get 8ABC somehow, and minus 4BC. And to do that, it seems I'll have something along the lines of 2A minus 1, 2B minus 1, and 2C minus 1. But what do I need to get that? Well, I need to have 2A plus B plus C and A minus 1. So I instead write this as 2a plus 2b plus 2c minus 1. That's also equal to 1 minus 4ab minus 4ac minus 4bc plus 8abc. And now if we actually try to factor it like this, we'll get that we're good. We actually can factor it like this. We get 2a minus 1, 2b minus 1, 2c minus 1 needs to be less than 0. And this is true. Why? Well, this factors into, if I put 1, instead of 1 I put a plus b plus c. This turns into a minus b minus c times b minus a minus c times c minus a minus b is less than 0. Given all of these are negative due to the triangle inequality, we're done. Now, this involves some luck, right? I mean, to me at least, it seems like it involves some luck, figuring out, oh, let me actually factor this like this, and it will all be good. And I think, actually, I might have just gotten points because I had 1 is less than 2c and 2a and 2b, something like that. So it's important. So the first lesson is it's important to write down these ideas that you get so that you may get potentially some partial credit. But the other sort of idea I want to show you is how you can use that something is a triangle, that ABC are lengths of a triangle. And this is, I think, called Ravi substitution method, which is if you put in the in circle, every triangle has an in circle. And then the side length, and then from the in circle, if this is ABC, you have this is equal to this is equal to this, and this side is equal to this side. So label these x, x, y, y, z, z, and then you get a is equal to x plus z, B is equal to y plus z, and C is equal to x plus y for some x, y, z, which are positive real numbers. And once you set ABC to this, you have effectively used the fact that this is a triangle. That's enough, right? If for any x, y, and z, which are positive real numbers, there exists a triangle with these side lengths. And but what matters to you is that for every triangle with these side lengths, you've completely used the condition that ABC are side lengths of a triangle by setting them like this. And you can find x, y, and z. For example, x is a plus c minus b over 2, right? And now if I just put that in here, this inequality transforms into this thing right here. Once you set them all up and get this out. So now it's still tough to actually do to now try to multiply everything through. But if we multiply everything through, we must get the correct inequality. In fact, here what I personally would do is I would divide everything up by 4. And now what happens is I get 1 over 8. Here I get this times a half. And why do I do this? Because I want to homogenize. What does that mean? I want to make everything be of the same degree. Which means what here? I want to use the fact that x plus y plus z is a half. The surest way to do that is to then multiply this by x plus y plus z. Then this thing will be of the power 3. This will be of the power 3. And I do x plus y plus z cubed here. This is equal to that. And then I have a homogeneous inequality that I can go ahead and try and prove. Truth be told, I haven't done this before making the video, and I also see maybe potentially we could try to get x, y, z down here. We can write this as 1 minus a half minus z, a half minus x, a half minus y. And multiply those through, and then maybe something cancels out, maybe not. But it seems to me to just be quick. Or maybe this, it's debatable which way is quicker now. But that is what we can do. So this is equal to x plus y plus z cubed. And this is equal to x plus y plus z. And now this needs to hold true. So how can we solve this? Well, this is then equal to x cubed plus xy squared plus xz squared plus x squared y plus xyz plus x squared z. And then similar for y and z. Let's see, just do any of these things combine? I have x squared, xy squared, x squared y, x squared z, xyz. No, nothing combines here. So we'll have then. That's actually kind of interesting that nothing combines. Oh, actually, wait a second. We can actually, instead of just multiplying everything through, let's write this as x plus y plus z minus xy minus xyz minus x plus z. So we'll have this as x plus y plus z cubed minus x plus y plus z times xy plus yz plus zx. And now I see this is going to be much quicker. Then this is x plus y, y plus z, z plus x. This whole thing needs to be less than x plus y plus z cubed. These two cancel out, and we need to have that this whole thing is true if and only if x plus y plus z times xy plus yz plus zx is greater than x plus y, y plus z, z plus x. And when you multiply everything through and cancel things out, all the terms cancel out, and you get 3xyz here, you get 2xyz here, and you cancel those two out as well, and you get xyz needs to be greater than 0, which is true because xyz are positive real numbers. So because this is true, this inequality is true. We've only done ifs and only ifs. And that's a different way to solve the problem. Nobody solved this problem. 4 was the highest result. But it's a geometry sort of inequality, what I wanted to show you was one, the factorization, which is the official solution, and the secondly being this sort of thing where you're trying to like just use the fact that it's a triangle, forget about the fact that it's a triangle, and then just do this. And that finishes up the problem. Now, a year later, I came to the same competition and I was first. I almost had 40 out of 40, though there were a couple of mistakes I made. This finishes up the problem. We learned something here, and as always, thanks for problem solving.